Hi, 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 hi. It doesn't, it's working. So, yeah, I can start. Okay. Hi, everyone. Thanks a lot for coming. I really appreciate it. And today we're going to talk about AI in performance testing, how we can use it, can we apply it, can we trust it, and etc. So first of all, a little bit about me. My name is, no, okay, sorry. It's very slow. My name is Raisa. I graduated from computer science department. I have more than 14 years of experience in QA, in managing teams, and last 5 years I'm working as a performance engineer, team lead of performance team at Ring Central. Here in Valencia we have office of Ring Central. My mission for the last 5 or 6 years is to change the view on QA as a process and on quality engineers as engineers with special skills and special. Okay, forgot the word. What I'm doing for this, I'm organizing events like QA Breakfast here in Valencia. I'm teaching, mentoring, and for the last 2 or 3 years, I'm also helping companies to organize QA processes, to educate team, and sometimes I'm doing QA audit. So here you have here QR code. If you're interested in QA breakfast, they call it like a QA, but there are a lot of people who are not from the who doesn't have a QA title as a position. So we discuss very different topics. You're welcome to come and bring your topics. It's very interesting, and it's a part of QA to know different knowledge from the different areas. It's very developing. So let's go into the topic. Today we are going to discuss what is performance testing, how it may look like, because in different companies and different processes it can look very different. What challenges performance testing has right now, and how AI can help us. Is it helpful? So let's start. Who actually knows what is performance testing? Can you raise a hand? Okay, who is working as a performance testing engineer, performance engineer? So yeah, so let's just revise for those who knows and new for those who doesn't know. So what is performance testing? It's a type of testing, actually it's a whole direction of the testing that has its own testing types. The goal of the performance testing is to understand how the system behaves under the load. The answers that we should answer by this testing is how we can handle some amount of users, like 10K, like here in the example. How fast the system operates under the load. Sometimes we even have in requirements something like SLA, so the request response time should be not more than, I don't know, 200 milliseconds. So we should answer that we should prove that the system works with these SLAs. A little bit about performance testing types. There are a lot of them. Yesterday I invented an explanation how they are differentiating between each other. So we are talking in 3 dimensions. It's rate, it's volume of data. So rate, it's request rate from the users, from the systems. Doesn't matter volume. So volume of data that is sent through the system pipelines, and time. So all of these types, load testing, stress testing, scalability, volume testing, it's capacity and endurance. We also have such a term like longevity. I actually know only, I heard it only once at Motorola Solutions 10 years ago. So all of these testing types differentiate from each other by these 3 dimensions. So what is load testing? Is some like 10K requests rate we should handle. What is usually to understand for new systems, usually to understand the level of load, we should make a capacity testing. So we should find the line that system hits after which we have a degradation. It's a little bit harder, so it's a very simple explanation, but still. Stress testing is when we have amount of loads that our system is handled. So we making more load and probably sometimes more time to understand that system behaves normally, probably not very good, but still handles the requests, not falling down, etc. Scalability, when we test that under stress testing, we can scale up our system and understand that the load is spreaded correctly, and it sounds very simple, but no one system doing it from the box. It's quite a difficult architecture to support after-scale or even manual scale and downscale back. Volume testing, it's about volume of data that we pass through, that our system can pass. And spike testing, it's rate of load for the short period of time, and longevity or endurance testing is when we making load for a huge amount of time, like days, weeks, months, etc. So it's a little bit about testing types. Stages of performance testing, what we usually do. It consists from requirements analysis, as usual, configuration of the, or sometimes even creation of the test environment, developing load models, selection of the selection of the tools for the performance testing, creation and debugging test scenarios, and analysis. From how it can look like. I will show it on our system. It's a huge system, enterprise. It's still smaller size of it, just for example. So for example, we have a system under test. It consists of some databases, some components, replicas of these components. So for example, in our just performance environment, we have more than 100 components only on one environment, and it is not a copy of production. It's a proportion from production, 130, 120, I don't remember exact proportion. So we have environment and deployed system. What we should do, we should create profile and generate load from this profile. So we have special load generators that send for the system some load according to profile. The important part of this is monitoring and logging systems, because we should not only send requests and say, okay, it's going something happening over there. We should check and verify. To do this, we should have monitoring system, and it's important part of the performance testing. On our environment, and I believe on all of them, as I didn't mention, but I will mention right now, I'm working in messaging department, in messaging backend, and this messaging part is one part of the huger system, and we connect it to the huger system also, but as if you work with huge systems, you know that it's very expensive to have expensive and not effective to have the whole system, even in environment size. So we mocked all the system from that is not connected to the system under test to have more correct results. These mock servers and load generators are also must be monitored to understand that the load we send, that the load generators are also working correctly and according profile, and the hardware, software under it also operating correctly and with a good performance. So it's how it looks in our system a little bit, and what challenges we have. And I believe not only we, but the whole performance area. So as we already discussed the stages, from my point of view, the first two are not very challenging because, for example, for enterprise systems, you do it like once in like some period of time. So for example, we did it once like some years ago. We repeated something 2 years ago when we created new performance environment, or if we have some new performance ideas for performance tests, and we should have like new tests. For example, we made a test for database, so it's different a little bit environment, but it's a whole different thing. So the challenging thing is developing of load model or profile. And for example, for our system, it is not, it's critical, but it's also not very challenging because we did it once time in some period of time. So it's not repetitive like everyday task. The next one, selection of load frameworks, tools, and creation test scripts, also not very challenging, because if you are working for the large period of time or for the future, you create it once and then updating all the time, but still it's not critical and frustrating. But conducting the testing can be frustrating because you do it like every day. For example, we have 2 environments, we do it every day on 2 environments, we repeated it all the time. And here I wanted to emphasize that not so challenging the testing itself, challenging its time for testing. So if you make any mistake, it takes like 4 or 5 hours to understand that you made a mistake. Even if you have a monitoring system, you do not monitor it in real time. Like we have 30 or 40 unique components, so it's 30 or 40 dashboards that we should look through, or write some automation to look it through for the testing period. For me and my team, I believe the most critical tasks and most challenging, most time-consuming is analysis of the results. It's especially difficult for the systems, for the huge systems with APIs that requests, when you have one API that internally requests 10 different APIs. So you cannot just say that, okay, I have degradation on 10% on all APIs. You actually don't know, because it could, in reality, it could sum the degradation. So the actual degradation could be 10 times more than you see. Okay, this is the challenges as a summary. So it's profile creation, it's a challenge, metrics analysis, time to get results, so tests, huge environment to support. Actually, it's also quite challenging. And what we didn't mention, but it's still important part of the process of performance testing, is when you find a degradation and you sit with a team of 10, 15 people and trying to understand for the 15 days like what is actually going on, where it comes from. It's not all the time clear. So how and where AI can help us? when we're talking about metrics and profile creation, it's usually work with a huge amount of data. And if you're aware with AI, if you use something, you probably understand that it's the best work for AI, especially when the data is structured. And probably it's not only in our environment, it's a common thing in performance testing that the data really structured quite enough, and AI can handle it even without any special preparation, and I'll show you later. Next thing, time to get results. The world, the best practices shows that we have already some even paid tools with licenses which are doing anomalies detection that we can use just from the box, or we can create our model to do this, like if it's cheaper. Where also huge environments, it's also probably about such tools like anomalies detection. We could detect rate of errors from logs. Again, the logs, it's data, very structured, and AI can help grouping the errors, and probably if it has access to the historical data, also it can understand if these errors like all the time or it's new ones, and make an alerts to you earlier. I probably now or later explain you why it's important. And issues investigation, it connects it especially to performance tests, and I believe that to performance to investigations that are conducted on productions. Why such things like anomalies detections, from my point of view, very important. From the experience that I have for the last 5 years, all huge outages or issues on production could be caught earlier, and probably for the period of time that from when the system actually showed us something to the period of time when system downs, we could already solve it. So we will discuss a little bit later. So for my team, the most critical are metrics analysis, as I already told, because we spent, so we have 2 environments, so 2 engineers running the test. It's all automated, okay? We just push the button and getting the results on Wiki page with some done analysis, but we still should make manual checking that everything is okay and make our conclusion. So it takes even for a senior titled engineer like 1 or 2 hours, and if we have a degradation, it takes much more. And time to results, as I already told, so sometimes we make mistakes and we know about this only in 4 or 5 hours after test, and after spending time to analyze report. So it's also like a day. And issue investigations, it's very time consuming, and we actually make some routine work there, and it can be handled even by some automation. So we tried to apply something I will show you right now. As I told, the data is quite structured. We have already a lot of automation for the period of time that we work. This automation creates a report, so it's already going to metrics database, gathering metrics, analyzes, making aggregations, percentiles, average, I don't know, everything that we need for every metrics. So you can imagine that It's 100 components. It's also more than 100 roads. So we gather this information, pre-analyze it, and here you see one, for example, Gatling. It's easier to find, I believe. I have such feature here. Okay. Gatling results. It's actually results for endpoints from the current test that we are testing. Gatling baseline, it's a baseline that we have for the same endpoints from the previous release. So we use such approach, like we have baseline for the previous release and we test a new release according to previous release. If it works okay, then it's okay. And we have already actually automated diff with the percentage of what is going wrong, what is going well, and these tables, actually there are tables there, we use to analyze manually. So we have already data. So what inside this data? It's something like this. So it's tables in the TXT format. It's in JSON. It's just an example. We have like huge, big files there. What I did, as I cannot just handle this work to any AI in the world, I should use only that our company supported. So I just opened it into Cursor like a project, the whole folder with the whole data, and ask it not a very with a not very good prompt. It was the first try, but I wanted to show you that even without any preparation or any good prompt, you are getting very good results. My idea was that we actually had some report which had critical issues. My idea was that I wanted to get the same results from AI, and we get it. So I know, for me it's important that AI won't say that it's okay, go to production. So, and it doesn't say so. And I like it. Actually, it makes so good analysis that we some things missed because we usually like, oh, it's like we know this, you know, like this. But the AI doesn't know this. So here it says actually it was approach that AI is going to do while it analyzes metrics. So you can change the prompt, you can say some insights to it, so it will use it. But yeah, as I told, he told that the release has significant degradation, and you have to look. Actually, under this, it's cutted output, as you understand. There are a lot of information there, a lot of different summaries. I like it very much. But I didn't stop there, so I tried to use GEM. I don't know, GEMS or GEM. So it's a Gemini bot, like a custom GPT. You can, like an AI assistant, you can teach it, you can, so not to have all the time prompts, you can give it rules to this gem, give it even files to educate if you have it. For example, we can ask him to use our old reports and the results that we have for education, you know, like here, look, we are thinking about these reports, do the same. And I just passed to him also these files and get the same conclusion, even a little bit better, because it's the Gemini actually narrowed down the actual issue that it was. So it was, for me, it was very important and useful. So you can imagine that even using UI AI bot, so manually, you can already save a lot of time like you get an answer for 10 minutes, and if you configure it correctly and use API, you can get the results already in your wiki page automatically. So for me, it's important, and I believe that we will introduce it in our actual work in a week or two, and save 4 hours a day for 2 engineers at least. The next thing that I really want to implement, and I want actually to have it in production, is anomalous detection. So anomaly is when something is going wrong. Yeah. So for example, you have normally load for 10K, and in some, or okay, we do not have such load in production. Yeah. You have like the period of when everybody sleeps, then they wake up and coming to work, then they going home. So we have something like this, and anomaly is when, for example, we have like still time, you have some load, and or when you have your peak time, you have some rate of errors increased. And as I already told in the beginning, usually all the outages are happening not right here. They are starting from errors, from something. So, and how the world sells this, that anomalous detection can be done using historical data of the production, all the production, and to predict and forecast. Actually, I have the slide for this, and forecast the load. So, for example, it sees that load started increasing, not in the peak time, but not in the regular way. It could alert you before your alerts are that you configured worked. I believe it's like a future and very helpful in performance testing, because it can increase time for tests. For example, in 30 minutes of the test, it could say us, stop this, please go and check your configuration, something, environment, etc. World's practices. For the last months, I read a lot of resources, made a lot of deep search using AI, and they also solving these issues. Every company, I believe, every performance team, we have challenges in metrics analysis with working with a huge environment, huge amount of data, and we are trying to solve this. Yeah, and even such big companies like Netflix, Facebook, Google, and IBM. So Netflix has something different, which we didn't talk about, but it's also important. We sometimes, and all the time, we also test performance tests under some HA scenarios to understand that our system is reliable and resistant. So it's called like house testing and HA testing. It's a lot of kind of testing. So they have a tool, you probably heard about it. It's Monkey House. Yeah, I believe it. IBM has tool for root cause analysis, Watson. I don't remember, but I believe that it's open free tool to use. And what was important for me, that we are thinking right now, so use what to use paid instruments, or teach our model for performance analysis. And such companies like Facebook and Google, so they have their own LLMs that they teach, and they also solving this issue, analysis, profile creation. And when we are talking about some simple tests or one component performance testing of one component, probably you can hand over all the testing to AI because it's quite simple. You can just say that you want such rate, use this tool. It will even create you a profile, a test scenario, and running of this test. Even we have some tools for this. Conclusion. We are finishing, so my conclusion is that AI can help us because we have a lot of repetitive tasks, a huge amount of data. We're making a lot of manual work for analysis, even if it is automated. And it could complement performance testing with a real-time analysis. And in the future, probably we will also use it to create profiles from the production with some automated tools and AI. That's it from my side. I will happy to answer the questions if you have. So subscribe me to LinkedIn. You can ask me even after this session. Thank you very much. Any questions?
Hi. For the anomaly detection, which is the time frame that you use to compare the past data with the current data?
Let me rephrase probably so I get information correctly, the question. So you are asking how all data in the past we used to understand. We don't. As I told, we want to use it, and I think that it depends on the costs of the data that we could pass to this. So probably it should be, it definitely should be something about working days. So it's at least 5 days of week probably, because it, from my point of view, yeah, I'm just imagining, I'm just making up this information. So from my point of view, it should be like a week at least, because we end not the week with the holidays. So in the area where you deploy your system, where you support it. Because for me, it's enough to get all the cases, all the information, and the patterns.
Hello, thank you for the nice talk. I wanted to ask you if I understood right that this AI can help us in order to find things that it's not so obvious to us, in order to process and to improve different data that we could go through it manually or ad hoc basis. But what's your take on using this technology or ideas to merge it with more automated processes, maybe continuous integration or something like that? Do you see it more as ad hoc help or something that can be integrated? And if so, if the integration can happen with the AI systems happening inside every time, or just being consulted outside and then introducing that new knowledge in the automated cycle? Not sure if I explained well. Sorry, it was a bit.
Yeah, I got it. As I told before, the guys from my work, so the things that we actually do, I believe that they are like already knows about this. So, we have a huge amount of automation, and we already, as I told, that we click the button and have results on Wiki page. So what is happening on this button? It's CI/CD pipeline that is start environment, start the cluster, scale it up, checking that service checks for all components are okay, checking that all the logs, index logs are appeared in Kibana, checking errors, and after that running warm-up, because we should warm the database, otherwise we will get different results all the time. So making warm-up, after that checking that warm-up was okay, and after that starting test case scenario for the 4 hours. After that it handles artifacts to the other pipeline that is generating these data reports that I showed you in the folder. These artifacts are passing to the other automation that is generating from it a wiki page with some pre-analysis, with the configuration, with the versions on the environment that are deployed, with some configuration files, etc. So we get the information there. And yeah, as I told, so the next step, so even now we can use it manually, it helps. It is AI even doing it a little bit better than me, than us, yes, because it can handle a lot of data, and it doesn't matter which, but the next step is use API of any AI to have this information already prepared in the report. So, yeah.
Okay, that's interesting, and also thinking that even the testing tool companies could also maybe improve their, because for example, Gatling, as you showed, it shows a little bit of clever analysis, you know, on their wiki page and in the results HTML page.
Yeah.
But like you said, maybe, I mean, I'm talking about something more standard or what they normally apply. But yeah,
it's actually my bad, because I thought about this several times, that we use Gatling. Why not any research gives Gatling as a tool which supports AI, but I believe that they're doing something, and my bad that I haven't yet read the documentation. Probably they have something, because I know definitely Load Runner and Gmeter has some tools, some plugins with AI.
Okay, thank you.
It's here.
Thank you. Thank you so much. And my question is, do you check the results from LLM after they answer? And if yes, how long, how time it took?
I did funny thing, because yeah, I checked the summaries at least, and I took several reports. For me, it was also important to ask AI if it handles the reports that we mark as passed. And it is doing so, which makes me happy. And what I did, I copied the summaries that we have and the summaries that it have, and asked to compare. So, yeah, first of all, I checked the conclusion. They are good, and the results in one report, it had AI told that we have some degradation, and I will on Monday check it actually was it so or not. So yeah, and of course I'm checking the.
Thank you.
This. I believe that it's important and very important question, because from time to time, AI hallucinating and giving you like something, you're like, what? But probably, as we only introducing this, we will firstly, of course, check the results, and probably if it doing so like even in 10 times, probably it's not. It's like a risk that we are okay to take. because people also make mistakes, so probably even more often. So I think that's it. Thank you very much for coming, for listening to me. So let's be in touch.
Thank you very much.
Thank you.